Hi, my name is Brian Poling. I'm a co-founder and the chief engineer at Syntex Systems LLC. This video is a demonstration of an open-source multi-vehicle ground control station program called Recon, which is being developed in support of a USDA NIFA project titled Multi-Vehicle Systems for Collecting Shadow-Free Imagery in Precision Agriculture. Recon is being developed by Syntex Systems LLC in conjunction with the University of Illinois at Urbana-Champaign, Stanford University, and the University of California, Berkeley. The goal of this project is to deploy a team of drones to collaboratively survey an area, in our specific case an agricultural field, while sensing and avoiding shadows cast by low-altitude cumulus clouds, which can otherwise confuse the interpretation of survey imagery. We use the terms sense and avoid for simplicity, but our specific aim is to track shadows, predict their evolution into the near future, and task our available drones in such a way that we image an entire survey area with sufficient overlap and sidelap for scene reconstruction, while ensuring that each point is imaged at least once while not in shadow. This enables shadow-free 3D reconstruction and mosaicing, even if clouds were present at the time of sensing. Distributing the workload for survey flights across multiple drones and extending the range of weather conditions under which imagery can be collected enables deployment of small UAS over agricultural fields of realistic industrial scales and under more typical weather conditions. Before looking at the software, we'll take a quick look at the hardware architecture employed by this system. Recon runs on a laptop configured as a Wi-Fi hotspot. A supported DJI drone connects to Recon through a companion app running on an iOS device connected to the drone's controller. This iOS device connects to the laptop over Wi-Fi. There is no specific limit to the number of drones that can be connected at one time, but there are practical issues of comlink interference if too many are used at once. So far, we have flown successfully with 4 drones at one time. Currently, only DJI drones are supported, but support for other drone manufacturers can be added in the future through new vehicle interface modules. Okay, so this is the main window for Recon, and you can see the primary widget here is a satellite map with various layers rendered on top of it. The first layer that you're seeing right now is the minimum safe altitude layer, which encodes the minimum safe absolute WGS-84 altitude, where a drone can fly without having to worry about hitting stationary or static obstacles like trees, for instance. Outside of this area that we've surveyed, you can see these red striped lines. This indicates no-fly zones. There is no minimum safe altitude in these areas because you're not allowed to fly in these areas at all. I can zoom in here. I'll activate an overlay, and we can see what these minimum safe altitudes are. In this area, this is an open field, the minimum safe altitude is 300 meters above the reference ellipsoid. Now we've already surveyed this site, and we know that along this line there's a low power line, which is why the minimum safe altitude increases by 30 feet about to 310 meters. Further over here, there's a tree line, which is why the minimum safe altitude increases to 330 meters. Okay, in addition to that, and I will turn that layer off now, we have avoidance zones, which we don't have any currently on the map, and safe landing zones. Avoidance zones are meant to represent areas where you can technically pass over with a drone, but which you cannot engage in sustained flight. To use more modern FAA terminology, you can transit through these areas, but you cannot have sustained flight. And then the green areas here represent safe landing zones, which are locations where, in spite of the minimum safe altitude, it is safe for a drone to descend all the way to the ground, and so land and take off from these locations. Now, all of these layers are stored locally on the computer that Recon is running on, and each of these can be edited from within Recon. You don't need to use a separate tool to edit these layers. So to give an example of this, we're going to activate the landing zones tool, and we're going to make a new landing zone. So I'm going to go 3 meters by 3 meters, and that gives me basically a brush that's 3 meters by 3 meters, and I can click and make a new landing zone, or I can just paint my landing zone on top of the satellite map. Now there's no load save dynamic here. This is an integrated GIS system inside Recon, which saves all of this in a registered, basically a raster data pyramid, and it's sort of automatically saved and automatically loaded based on the location that you're looking at. So if I close the application and reopen it, go back to that spot, we can see that it's exactly how we left it. So let me go ahead and erase this. Yeah, we'll use a circle brush to erase it. So editing data is basically that simple. Now we can also change how these various layers are rendered. We can edit opacity of all of them. Usually want something a little less than 100 so we can see all of the different layers. And we can change the range for the color map, which is what values correspond to the extreme colors, so in this case blue to red, and we can change how no-fly zones are represented. And we can change opacities of these other layers as well. Now, in addition to the environmental layers, we have a concept of a survey region in Recon, and a survey region represents a location that you may want to fly over and collect, imagery that you may want to then use structure for motion on to build 3D reconstruction or mosaics of. They're areas you want to survey. I will turn this on. You can have as many survey regions as you want. Each one of these is basically saved to a file on your computer, and you have one of them active at a given time. So right now, this is the active region. It's called Foley Region A. And if I want to edit this, I just turn on the Survey Region tool, and we can manipulate these polygons. A survey region internally is represented as a union of polygons, which each of which may have holes. So here's an example of a polygon with a hole, and here's a polygon without a hole, and our region is the union of these two. So we can just click and drag to manipulate the boundaries of these things, and we can also make a new polygon or a new hole using this, just like that. And if I want to delete something that I've created, oops, I missed it, just like that. Alright, so I'll turn that tool off now. There are additional overlays for various modules which are not currently running. We have a guidance overlay. There's a guidance module which is responsible for tasking drones when we're doing a survey mission. And then there's a shadow map and time available overlay which show us information coming from our shadow detection and shadow propagation modules. Okay, for an actual demonstration of using this system with actual connected vehicles, we're going to switch over to a live stream from an actual test flight that we did in Foley, Minnesota. Please note that in the United States, the FAA does not currently allow a single person to serve as a remote pilot in command for multiple vehicles simultaneously. We're flying with an operational waiver that permits it, and as required by our waiver, a NOTAM was issued 24 hours in advance of this flight. If you plan to use Recon with multiple vehicles at one time, be aware that you need a different RPIC assigned to each vehicle, or you need a waiver from the FAA. Here you can see 4 drones connected to Recon. Each drone appears both on the map and on the Connected Vehicles widget on the lower left. Each drone gets a unique number assigned to it, which appears in both places. Right-clicking on a drone opens a context menu for issuing commands to the drone. You can also access all vehicle info and capabilities through the Connected Vehicles widget. Here, we issue the takeoff and hover command through the right-click menu. If we take off in this way, the drone defaults to click and drag control. We can right-click on the drone to change the commanded vehicle state, including height above ground, yaw, and movement speed. To move the drone horizontally, we simply click and drag on the drone and release over the location we want the drone to move to. This drone is equipped with a DJI ZenMuse camera with a fisheye lens, and you can see the video feed from this drone in the upper right-hand corner of the screen. We're now going to manually take off and position the other 3 drones. this flight test, we're going to position each drone initially at a different height above ground to minimize collision risk. To demonstrate how we can change the commanded state of a drone other than its position, we're going to open the right-click menu again and change its orientation. This can be done either by manually specifying yaw or by clicking anywhere on the right portion of this widget. We're now going to manually space out the drones before sending 2 of them on waypoint missions.
Southwest road. This one here.
In practice, waypoint missions will be generated algorithmically by the Guidance Module in order to cover the active survey region. For this flight test, however, we are sending the drones on pre-generated flight patterns.
Yeah, just a sec. He's doing a waypoint mission. Moving all 3 of them now. The low flyers.
The drones function independently, and as you can see, certain drones can be flying waypoint missions while others can be under manual click and drag control. Full telemetry for any drone can be viewed through the Connected Vehicles widget. There are several built-in safety features, including a Watchdog module that looks for vehicle collision hazards, along with violations of no-fly zones, avoidance zones, and minimum safe altitude. These checks all rely on the integrated GIS system that we showed earlier in the video. The Watchdog Module uses audio and visual hazard indicators and can be set to automatically stop and hover drones involved in a hazard. This module looks ahead in time to try and prevent collisions and other hazards before they happen. In addition to this Watchdog, there is an emergency menu that allows certain commands to be issued to all drones immediately and simultaneously. There are currently 2 emergency commands. The first instructs all drones to stop all motion and hold their current positions. The second command similarly stops all horizontal motion, but commands each drone to drop to the minimum safe altitude for its current location. This is meant primarily for responding to unexpected air traffic, when there may not be time to manually move each drone in sequence. Here we're going to send 2 drones in motion, and then issue the all drones stop and hover command. A drone can be manually instructed to land in 2 ways. There is a return home and land action, which activates the drone's built-in return to launch functionality. There is also a land now action, which lands at the drone's current position. Both actions can be accessed through the Connected Vehicles widget or by right-clicking on a drone. This concludes this video demonstration of Recon. Check back because we plan to post additional videos in the future to demonstrate the shadow detection and vehicle guidance capabilities. Thank you.